Hi, I just wanted to cover some topics that some people are struggling with. So, get my pen here. There we go. All right, so mainly I want to cover independent versus Paired-t tests. All right, so what does independent mean? We've been using that all semester. So independent observations means, this is what it means. All right, the outcome of one observation doesn't affect, and when I say doesn't affect, I mean it doesn't change the probability of just the distribution of another observation. All right. So I was looking at heights of people, and I said, okay, what's your height? Oh, you're 5'4". Well, that's not going to have an effect on the next person's height. They're independent. The heights are independent. But if you were best friends, and I asked you, what's some political opinion? All right. If one of you said, "Oh, I'm a Democrat," well, your friend is more likely to be Democrat now that I know that you are. Because people who hang out with each other, they affect each other. Now, that doesn't mean that all of your friends are Democrats, but if I know you are, and this is your best friend, then that person is more likely to be Democrat, right? So your friends, regarding political opinion, your friends' opinions are not independent of each other. Okay. Now, when we collect a sample, we want all the observations to be independent of each other. All right. So we're trying to get a good representation of the population. So I don't want to have bias where I happen to get a bunch of people that are related to each other, because those related people may not be representative of the population. All right. So I want my observations to be independent. All right. But in certain kinds of tests, I am looking like paired tests. Then I have pairs of observations. It's like, here's you and your best friend, right? You're related to each other. But if I had another set of best friends, right? So here's friend, here you guys are friends. So these two people, they're best friends with each other. These two people are best friends with each other, all right? This person is not independent of this person. And same with this. This person is not independent of this person. But when I collect my sample of pairs, I want this group of best friends to be independent of this group of best friends. So my rows are independent, but my columns are dependent, not independent. All right, so with a paired test, I have one person over here that's going to go specifically with only one person over here. So my data is paired. It's in groups of two that are not independent of each other. All right. So let me see. Here we go. Are husbands older than wives on average? Are husbands and wives independent when it comes to age? All right. So if I know the husband's age, let's say the husband, he is 80 years old. All right. And then I say, well, what's the wife's age? I wouldn't say, well, I have no idea whatsoever. No, I have some idea. It's probably around 80, right? Maybe a few years younger. because husbands tend to be, a few years older, but wife is, her age is now going to be close to 80. So her age is not independent of the husband's age. Now, when I look at all the different couples, their difference in age may be independent of each other. So here's one couple, and then I go to another couple. Their difference in age might be independent of how the different age of this couple, but this is paired. This is a paired t-test because I've got husband and wives. I've got twosomes. A pair is a twosome. All right, so then I've got 100 couples. A couple is a pair. All right, now this one, I have 200 students, and I want to know if the average age of the women is different from the average age of the men. Well, here I randomly sampled, so I've got a random sample of 200 students. Because I've used a random sample, none of the students are related to each other. They're not connected to each other. So all 200 are independent of each other. All right, so if I split that up and let's say there's 115 women and 85 men, I'm just guessing. Well, this could happen. Well, the height, or age, the age of a woman over here, I can't pick a woman and say, okay, woman number 5, All right. Which man does she get with, Which man do I match her up with? I can't. None of them. They're unrelated to each other. So this is not paired. This is an independent t-test. All right. Let's do a different one. Okay, now here's Jocko's garage. All right. Somebody thinks that he's charging a lot more than another garage. So what do? They take 10 damaged cars, the Jocko's, and then they take the same cars to the local garage. So here's my 10, here's my 10 quotes from Jocko's. And so let's say this one was $850, all right? Well, can I pair that up with the quotes from the local garage? Is this paired? The answer is yes, because this is the same car. So 850 at Jocko's, maybe it was 675 at the local place. So this car and this car are the same car. It's just a quote at a different garage. And the same is going to be true for all 10 cars. I'm going to have a quote for this car and this car. So if this quote was, $1,700, what's the quote going to be over here going to be? It's not independent. It's not like, oh, I have no idea. It's probably going to be around $1,700 because it's similar repair. I mean, this over here is $1,500. All right. So they're not independent. Knowing the price at Jocko's gives me an idea of what I expect from a local garage. So these are not independent. This is paired. This is a paired t-test. Now we come down here. It says peaches in California versus peaches in Georgia. So I've got here's my and let's see. Are they larger? So maybe we measure the circumference. So here's my California peach. I got 100 of these, and I got 100 from Georgia. Let's say I got 100 peaches from both places, and I measure the circumference. And this one's 5 inches, and this one is 7 inches, and so on. All right. Does this particular peach, can I match up that particular peach with a specific peach from Georgia? No, it's the first peach over here. It's not like, oh, the first peach from California is somehow related to the first peach from Georgia. No, these are independent. This is an independent t-test. Okay, so let's go back and look. The other type of test is a one sample t-test, right? So with an independent t-test and a paired t-test, I'm comparing two variables. Or I'm comparing, so I've got, with paired, so here's, I don't know, let's say the friends, well, it's not quantitative. I'm going to do a paired T on Democrat or Republican. Well, that's what we did with chi-square, but let's say the friend's GPA, and this, here's the best friend's GPA, right? So I've got two GPAs I'm comparing. Same with the independent sample. I have a measurement of the Georgia peaches, and so I'm comparing. With a one sample, I'm comparing a sample average to some baseline number. All right, so with a one sample t-test, I'm comparing I have one sample of data. Look at this and I say, was that average, is that the same as my Northern Kentucky, data set? Does that indicate that my Northern Kentucky is different from the national rate? So there's some other number, here's the national height of women, on average is 5'4". I take 50 from Northern Kentucky. Is their average 5'4"? All right, so when I look here, a principal suspects the mean standardized test score for a gifted teacher's class is higher than the national average of 75. So when I have a number to compare it to, that's going to be a one sample T. Here we got mu equals 75, and so it's mu is greater than 75. By the way, when I didn't finish these. All right, so for a paired test, this is about mu D. It's about the difference in the ages here. This D is the different, D stands for difference. And so we're testing if mu D is 0 versus if mu D is not 0. And then I look, and is it going to be not equal to, it says older than, so let's make this a greater than, well, where D is going to be the husband's age minus the wife's age. When I have independent tests, this is going to be about the difference in the two separate means. So there's the mean of the women and the mean of the men, right? So mu1 minus mu2, that this is 0. And let's see, average age is different. So since we're talking about things being different, this is going to be not equal to 0. Okay, I hope that clarifies some regarding the difference between independent samples and paired samples and one sample.